Hi students, today we are going to look at Bohr's radius of nth orbit. In our next video, we will look at Bohr's energy of nth orbit, right? Now, so according to Bohr, he has given some two postulates. So the first postulate is electrons cannot revolve around the nucleus in all the orbits. So we might have heard or learned that if this is the nucleus, these are the orbits of the electrons we are thinking, right? But even the electrons have orbits in this direction, along this direction, here like that. So these are also the orbits of electrons in different direction, that is oriented or inclined in different directions, right? Now he says that electrons cannot revolve around the nucleus in all the orbits. They can revolve only in those permissible or allowable orbits. Those orbits are called stationary orbits. So why did he call that as stationary orbit? So the stationary orbit, electron will not radiate any energy in the form of photons. So that is why it is called as a stationary orbit or stationary orbits. So electrons which are moving in the stationary orbits, they will not radiate any energy. Second postulate. So when can the electrons radiate energy? Whenever electron jumps from an orbit of higher energy level to an orbit of lower energy level, it radiates energy in the form of photons, right? So for example, in the first postulate, he says that the angular momentum of each electron is always equal to, so the angular momentum means mass into velocity into radius is always equal to nh by 2 pi. Right? So this is his first postulate. In the second postulate, he says that whenever electron jump from orbit of higher energy level to the orbit of lower energy level, it radiates energy. So E2 minus E1. So these are the difference between the two energy levels. It's equal to h nu, where h is the Planck's constant, nu is the frequency of the radiation emitted out. Right? Now, we are going to use the first postulate in this Bohr's radius of nth orbit. That is, we are going to find out the R suffix n. Now, see, consider a nucleus whose charge is q1, an electron in some nth orbit whose charge is q2. The distance between the nucleus and the electron is taken as radius of nth orbit, right? So here between these two, q1 and q2, there exists a force of attraction, or so negative, positive force of attraction, and this type of force here what we call as the electrostatic force of attraction between these two charges q1 and q2. So the charge of the electron is E, the charge of the nucleus is Z into E, that is charge of one proton into total number of protons. Now we know the electrostatic force of attraction between two charges is equal to 1 by 4 pi epsilon naught q1 q2 by Rn squared, since Rn is the radius of the nth orbit of an electron. So 1 by 4 pi epsilon naught, q1 is nothing but E, q2 is nothing but Ze by Rn squared. So Fe is nothing but Ze squared by 4 pi epsilon naught Rn squared. Sorry. Now, This electrostatic force of attraction provides the necessary centripetal force for the electron to move in a circular path. This electrostatic force of attraction, F suffix E, provides the necessary centripetal force for this electron to move in a circular path. So the centripetal force is provided by this F suffix E. I can write it as ZE squared by 4 pi epsilon naught Rn squared is equal to, so we know the formula for centripetal force, m into Vn squared by Rn, where V suffix n is the velocity of the electron in the nth orbit, right? We also know that Vn is equal to Rn into omega n. So the relation between linear velocity and angular velocity, right? Now I am substituting the value of this here. So let me keep this formula as a highlighted one. Vn squared. So Rn squared omega n squared by Rn. So one Rn will get cancelled. So at last I get. So let me write this. So at last I get omega n squared is equal to ZE squared by 4 pi epsilon naught Rn squared into Rn1 Rn cube into m. So here let me take this as equation 1 like that, this as equation A, right? Now by first postulate we know that m into Vn Rn is equal to nh by 2 pi. Again Vn is equal to Rn omega n. So m into Rn squared omega n is equal to nh by 2 pi. So let me wrap this. So here m into, I can also write this as omega n is equal to nh by 2 pi m Rn squared, squaring on both sides. Omega n squared is equal to n squared, h squared by 4 pi squared, m squared Rn power 4. Now take this equation as 2. Now compare the equation 1 and equation 2. We get comparing 1 and 2, we get n squared h squared by 4 pi squared m squared Rn power 4 is equal to ZE squared by 4 pi epsilon naught m Rn cube. 4 get cancelled, 1 pi will cancel, one m will cancel, Rn cube, Rn power 4, so 1 will be remaining there. So we need to find out only the Rn. So R suffix, this Rn goes here, R suffix n is equal to n squared h squared into epsilon naught divided by, here this pi, this 1m will go here, pi m is E squared. So R suffix n goes here, ZE squared comes down, pi m ZE squared, n squared h squared, epsilon goes there. So this is the radius of the electron in the nth orbit. But for, if I take, if I consider any hydrogen atom, for hydrogen atom, this Z equal to 1, right? So r n becomes n squared epsilon naught by pi m e square. So substituting the value of mass of electron, that is 9.1 into 10 to the power of minus 31, charge of electron 1.6 into 10 to the power of minus 19, epsilon naught 8.854 into 10 to the power of minus 12 c squared n inverse m power minus 2, h value 6.63 into 10 to the power of minus 34 joule second. So after substituting all the values, I get n squared into 0.53 angstrom. We know that 1 angstrom is equal to 10 to the power of 10 minus 10 meter, right? So this is when n is equal to 1 for the first orbit, r1 is equal to 1 squared 0.53 angstrom, that is 0.53 angstrom. This is called as Bohr's radius. So when n equal to 1 for the first orbit, the radius of the first orbit is always equal to the electrons has this. So 0.53 angstrom, radius of the electron in the first orbit is equal to this, right? So I think you must have understood the Bohr's radius of nth orbit. In the next video we will see Bohr's energy of the electron in the nth orbit, right? So thanks a lot, bye.